Now we're going to graph a system of linear inequalities, which means that we have two or more linear inequalities, and we have to try to find the set of solutions that will work in both. So I'm going to start just by graphing both of them, since they're both in y equals mx plus b form. I'm going to start by graphing the first one. I'm going to plot a point at -5 on the y-axis, and then I'm going to go up 1 and over 3, up 1 and over 3, and I'm going to connect those points with a dash line because there is not an or equal to. And I'm going to choose the point 0, 0 as my test point. So 0 is greater than 0 minus 5. 0 is greater than -5. That is true. So those points are correct. So I can actually shade very lightly above that inequality. Now let's check the second one. So I'm going to plot my first point at +1. And then I'm going to go down 2 and to the right 5. And I'm going to connect that with a solid line, not the most straight solid line. That's because it's an or equal to problem. I'm going to again check the point 0, 0 because it's not on the line. So 0 is less than or equal to 0 plus 1. 0 is less than or equal to 1. That again is true. So I'm going to find 0, 0. It's below the blue line, so I'm going to shade below the blue line. Now, when I'm doing these problems, I'm looking for the set of solutions that fit both of my inequalities. So looking at this graph as I have it right now, I'm looking at the area that's above the red line, but below the blue line. So I'm looking for this area here. I'm looking for that area. That is the area where all of my points will fit into both of my systems. So that's my solution area. So now I have a system of 3 inequalities. Well, first of all, I'm going to have to get all of the inequalities into a form so that I can graph them. So I'm going to take the top inequality and I'm going to divide both sides by 2. So that becomes 3x over 2 plus 1/2. So that's going to be tough to graph, but I'm going to do my best. I'm going to put a y-intercept at 1/2. I'm going to estimate that y-intercept. And then I'm going to go up 3 from there and over 2. Up 3 again, over 2. And I'm going to connect those points with a dash line. I'm going to check my test point. 0 is less than 0 plus 1/2. 0 is less than 1/2. So that is true. So I'm just going to draw an arrow pointing that I would shade below that line. Now let's try the one in red. So I'm going to add x to both sides. Then I'm going to have to divide by -1, and that means that my inequality sign is going to flip. So -x plus 2, or minus 2 rather. So I'm going to put my point at -2. I'm going to go down 1 over 1, down 1 over 1. I'm going to connect those points with a straight line in this case, although it didn't quite go through the points. And there's my straight line. Let's see if I can't move that over just a little bit. No, it doesn't look like I can. So I'll try my point 0, 0. 0 is greater than -2, so that is true. So 0, 0, which is above, should be shaded. So I'm going to shade above my red line, below my black line. So right now it looks to me like the area where I'm going to be shading is over here. This looks like the area where I'm going to have the black and the red. But I still have this third inequality. Y is less than -4. Now y equals 4 is just a horizontal line at 4. So I'm going to draw a horizontal dashed line at 4. It's dashed because it's not or equal to. And I know that I'm going to have to shade below because it's less than. So now I can look very carefully and I see area where the blue, the black, and the red are all intersecting. That area is right over in here. So this area that I'm shading right now is the set of solutions that would work in all 3 of my inequalities.